This is the final video of the course and will be a bit different from the previous ones. So far, we focused on how mechatronic systems work, communication, hardware, and software. Today, we'll step back and look at how to design these systems and what impact they have on the environment. The goal is not to add complexity, but to start thinking like responsible engineers from the beginning of your studies. In this video, there are four main objectives. First, to understand the environmental impact of mechatronic systems. Second, to introduce circular economy from an engineering perspective. Third, to identify simple, practical strategies for designing electronics and prototypes more sustainably. And finally, to discuss how educational hardware should be used, reused, and handled at the end of its life. Mechatronic systems combine electronics, mechanics, and software, which means they also combine the environmental impact. PCBs, motors, batteries, and plastics all require energy and raw materials to produce. As engineers, many of these impacts are determined by our design choices. So, sustainability is not something external to engineering. It is a part of good design. Most technology today follows a linear model: build, use, and discard. Circularity changes this approach by aiming to keep products and materials in use for as long as possible. For engineers, this means designing systems that can be repaired, upgraded, or reused. It's about thinking beyond the first use of a product. A large part of systems' environmental impact comes from manufacturing rather than operation. PCB production, electronic components, motors, and plastics are all energy intensive. Once a design is finalized, most of this impact is already fixed. That's why early decisions are so important. There are some simple strategies that improve sustainability without making systems worse. Designing for long life, repairability, and disassembly makes a big difference. Using standard components and avoiding unnecessary complexity also helps. In general, simpler and more modular designs tend to be more sustainable. In electronic design, sustainability often means simplicity. Smaller PCBs, fewer layers, and clear labeling reduce waste and make reuse easier. For educational systems, components that can be replaced or resoldered are especially valuable. PCBs should be as reusable tools, not disposable items. Electronic components and 3D printed parts are frequently wasted in educational projects. Many components can be desoldered and reused in future labs. With 3D printing, careful planning, and modular designs reduce material waste. Even failed or old parts can often be reused for learning purposes. Energy efficiency is another important sustainability factor. Oversized power supplies and inefficient motors waste energy. Simple practices like using silk molds and choosing efficient components can have a big impact. Rechargeable batteries should always be preferred when possible. To conclude, educational hardware should not be treated as disposable. All boards and systems can be reused for demonstrations, repairs, or components recovery. As engineers, our design decisions influence both performance and environmental impact. Learning to think sustainably from the start is a part of becoming a good engineer. This is the end of the video. Thank you for watching.